Hi, in today's class, we'll see the concept of relational schema. Generally, schema means a structure, right? Relational schema means structure of the table. How I am saying that it is structure of the table? Relation is the technical word in SQL for the table. Am I right? So I can call alternately either relation or a table. So that's the reason I am saying that relation schema means simply a structure of the table, right? Structure of the table is going to define what kind of data I am going to store in the table. Like I can say it as the type of the data types of the table what I am using, and also it will define the column names. What are the column names are available? What is the table name where I am storing the data? What kind of rules I am going to use in order to store the data? And what are the various kind of keys that I am using here? Right? Means, if I would like to say technically, what kind of data types means those can be integer data types, or it can be a double data type, or it can be a varchar type of data type, right? Yes. Varchar of some size 100. I can say that the data types that are going to be allowed in the database. Column names means it can be any kind of valid string names. Table name means also a kind of valid string name. Rules means when you are trying to define what type of data you are going to allow in the particular column. For example, if you are going to say that uh, the age column is there, right? In this particular age column, what type of data I want to store? I want to store only the age data should be greater than 18. That is what one kind of rule, right? Like that, if you would like to put some kind of restrictions on the table before inserting it into the table, I can go for defining its rules. Those I can technically call it as constraints. And various kind of keys that are supported by our table I can define as keys, primary keys, foreign keys. Like that, we are going to have various kind of keys are there. So simply, relational schema is going to define what is my table name, what are my column names, and what type of data type is allowed by each and every column name, what are the rules that are supposed to be satisfied by our table, and what are the various kind of keys that are supported by our table. Okay, fine. Now, I will try to explain here further concept, that is constraints. Constraints means simply a kind of rules, basically rules, right? So before going to insert certain data into the table, it has to satisfy first certain kind of rules which are given by us, right? So those rules, if we are going to define in technically, we can call it as constraints. Basically, these constraints are of two types. One is column level constraints, another one is table level constraints. Okay, column level constraints means these are the constraints which are going to apply on only one particular column. One particular column, I can call it as column level constraints. If you are going to apply certain kind of constraints on collection of columns, or I can call it as more than one column, I can call it as table level constraints. See, all the constraints comes under uh, column level constraint as well as table level constraint. So the way that we are going to define, depending on that, they are classified as column level as well as table level constraints. If you look into one kind of a constraint, that is, for example, not null constraint, right? Not null constraint means the respective column where we are going to use not null should not allow null values. Should not allow null values. Like for example, let us take, assume that student name is there, right? In this respective location, user should not enter the null values. So meaning that they has to enter compulsory their name. For example, let me take it as Jaya, or let me call it as a Krishna. Or sometimes users may not interested to enter the values. At the time, the data is going to be stored as null, but your relation is going to restrict that. Why it is restricting? Because we mentioned S name as not null. That's the thing. Okay, fine. How we are going to do it in real time means, first let me create one table. Create table. Table. Table name is, for example, assuming it as person. Table name is assume person, and person having person ID, which is of type integer, and person name having person name, which is of allowing of size of maximum of 100 characters. And here the person name has to be compulsory entered, meaning that it should not allow null values. Then I can able to use here as not null. Simply I can press enter. I have created a table with two columns. One is PID, another one is pname, where pname is not going to allow null values for you. That's why it is saying that for null respect to thing, pname is no. No means what? It is not going to allow null values. Whereas coming to PID, PID can able to allow null values according to this kind of particular requirement, right? Now, if I am trying to insert into table name is person, values of 1 comma, if I enter as CSC, which is going to be allowed. But if I am not interested to enter my name, not interested to enter my name, then I can define PID values of something like 535. Now this particular query is going to produce an error because field name p name does not have a default value. Means that first, as I didn't enter any value here, it is going to check for trying to place the null value, because we haven't given any data. But before going to place null value also, it is going to check for the default value, as user haven't given any data of pname. So as we didn't have given any kind of a default value, then it is going to say that error, because it is not going to place null value. See, I mean, here the point is, first, as we didn't enter any valid value for that, it is going to check for default value. But as we haven't placed any kind of a default value, it tried to place null value. Even when it tries to place null value, we have given a constraint called null constraint, that is not null constraint. It is going to simply throw an error there. Okay, fine. Let's see one more kind of constraint, that is unique constraint. This unique constraint says that we have to allow only unique values, meaning that it should not allow duplicate values. Okay, means if you are going to have a data as something like SID, where I can able to enter any H of data, but if I'm going to repeat the particular data of the same column, then it is going to say that you should have to only non-duplicate values, right? How we are going to do that? For example, let me create one particular table as create table person 1, and it's having the column name as PID and P name, where I am saying that PID is unique. I can define unique, which means we are applying a constraint called unique constraint. If you are going to describe it, describe person 1, right? So meaning that the kind of constraint what I am applying here as unique constraint means it has to allow only unique values, and also can it allow null values? Yes, it will allow one null value, because one single null value is also kind of unique value. Now if I am going to insert certain data into here, insert into person 1 values of 1 comma CSC. Okay, data entered perfectly. Next, I am going to insert one more data 2 comma CSC, no problem. If I am going to insert once again 1 comma, for example, EC, now it will throw an error. What is that error? Duplicate entry for the key PID, because one is already there. One is already there. Right? Try to check. Select star from person. Right? As one is already there, it is not going to allow to enter the value once again. Right? See, basically what will happen? This unique constraint or any kind of a constraint, you can able to use at the combination of more than one column also, right? At the time, what you can do now, you can simply use unique of column 1 comma column 2 and so on. That's it. At the end of the syntax, you can write this one, right? Meaning that this entire collection of columns should make the data should be unique. That is the meaning of unique constraint. Okay. Next, another kind of constraint is there. The constraint is default constraint. Default constraint says that when user is not entered any kind of a value, you have to place certain default value. Placing certain default value, I can say that this is default constraint. For example, user not interested to show enter any data in the name of yes name. I would like to place the default value as CSC. Default value as CSC when the user is not entered in data. Then what you can do? You can simply define the table, like for example, create table. Table name is something like person2, where it contains the column names as SID and data type, yes name as a column name, and its data type I am going to define, and I am going to define the keyword called default keyword. Default, what I am going to place? I am going to place here CSC. Then I can say that when user is not going to enter the S name, it is going to place the null, instead of placing null value, it is going to place CSC. Try to observe. I am going to create table person3 PID int pname varchar of 100. Okay, fine. Here I would like to explain the default constraint. So what you can do here, if the user is not entered any p name, you can just simply make use of default constraint. Default, what you have to place? Default as CS. If I press enter, it was created. Describe person3. Observe, there is a default value I have placed. The default value is CSC. Default value is CSC. Now, if I am going to enter certain data, insert into person3 values of 1 comma mechanical. Yes, inserted perfectly. Select star from person3. Yes, data is there. Data is there. Now I am trying to insert into person3. I am going to insert only PID. PID values of 535. If I press enter, is it going to be an error? No, there won't be any error, because we are going to have defined the default value as CSC. That default value is going to be stored here. This way you can able to use default constraint. Another kind of constraint is there, check constraint. So check constraint is going to define before going to insert data into the respective column, first it is going to satisfy the given condition. If it satisfies the given condition, it is going to allow to insert. Otherwise it will simply reject the respective data, meaning that it won't insert into the table. If you want to apply any kind of constraint, default constraint or unique constraint, not null constraint or check constraint, those constraints you can able to apply either at the time of creating the table or after the creation of the table by using alter command, right? Yes, you know that. Right, now I will try to write the syntax for how to create check constraints while creating the table. So I will use simply create table For example, table name is student and the column name is SID, which should be of type integer, and I am thinking that it should have the value should be greater than compulsory 10. So I can say that it I need to apply check constraint. Check what field I am trying to do for SID, it should be greater than 10, which means that whatever the data that I am trying to insert into the SID field, that should be greater than 10. That is the meaning of it, right? Similarly, S name, for example, it can be varchar of 100. So like this, you can able to create the check constraint. See, not only at the creation level, but also you can able to make it at the uh, after the creation of the table also using the alter command, right? Yes, and I am saying that these constraints can be created, and we can able to use that, right? So I can able to create it while adjacent to the corresponding column, or I can able to create at the end of the table, right? For example, I will try to create the check constraint at the end of the table. Create table student SID integer S name varchar of 100 varchar of 100, and I would like to apply the constraints on SID. So I can make as check constraint on what SID, that should be greater than 10, that should be greater than 10, right? This is the way I can do. But the thing is, sometimes you would like to uh, delete the constraints also at some time, right? At the time, what you have to do, you have to compulsory make use of alter command to delete the constraint, or else what you can do now, while creating the constraint itself, you can able to give the constraint name. Create table student SID, which is of type integer, S name varchar of 100, and as I'm trying to define the constraint name, I have to use a keyword called constraint keyword. So means I'm trying to define the constraint, and you have to define the constraint name followed by what is the constraint you are trying to define, check constraint, where SID should be greater than 10. See, like this, for any kind of constraint you can able to give the name of the constraint term, so that what we can do, we can directly remove that constraint easily with the help of constraint name. Okay, fine. So guys, if you would like to apply the check constraint, so for example, I'm trying to create table person, for example person 7, SID, or let me take it as PID, which is of type integer. I'm trying to define a check constraint here itself. Check constraint is my PID should be greater than 10, and P name, which should be varchar of 100. Okay, so table is created. If I am going to describe it, constraints are not going to show me this kind of constraints. Yes. Okay, fine. So meaning that here check constraints are created. Have you observed check constraints are created? No. Meaning that is here. See, observe. If you want, I will try to show here. Insert into person 7 values of 1 comma CSC. Guys, is 1 is a valid data according to the constraint? No, but it is going to be inserted. Select star from person 7. So 1 is inserted. Means here check constraints are not supported in MySQL, especially in my system. I mean, I am using here 8.00, right? So the Google is saying that these constraints are going to support it after the version of 8.0.16. So if you want to work with check constraint, you can go with this kind of version, so that you can able to work with the check constraints. Next kind of constraint, that is primary keys, right? We can call it as a keys also, primary keys. So primary keys means these are going to define the column as it should not allow null values, as well as the data which is present in the column should be unique. So primary key simply defines not null and unique. Not null and unique. How we are going to define that? I am going to create a table. Table name is person 8 SID int, and this table is primary key, and S name is varchar of 100. I have created the primary key. Now, if I are going to describe the person 8 table, you will get the key as primary key. Primary key. Now, if you would like to insert into person 8 values of 1 comma, for example, CSC, I have inserted. Now, if I am going to insert once again the same data, but with SID as 1, duplicate entry for key primary, meaning that it is not going to allow duplicate values, means it is going to allow only unique values. And what about the duplicate values, sorry, not null values? For example, insert into person 8 values of 2 comma, I am making uh, not to enter, right? So what I can do, I can modify the query like this, s side. If I enter, it is going to be affected. Insert into person 8. So why it has done? Because we are trying to insert into SID. So SID is not null. Select star from person 8. SID is not null, so it is going to be okay. But if I am trying to make SID as null, I am making it as S name here as EC. If I enter, we are going to get error. Right? SID doesn't having default value. Means I said already, right? So when you are trying to define, when you are not going to insert any value, first it is going to check for default value. Yes, there is no default value, so it will go for checking the null value. Yes, as defined not null constraint, so it is not going to allow null values also. So primary key value should be not null and it should be unique. Okay, fine. Next kind of constraint, that is foreign key constraint. Right? So foreign keys are like referential integrity constraints, which are meant for the purpose of to define the relationship between the tables, right? So how we are going to create the foreign key? So you can able to create the foreign key by using a keyword called foreign key of the column name. This defines for what column you are making it as a foreign key, and you have to make sure that to write references keyword. Okay, references keyword, and this particular foreign key column should be referred to which one? It should be the other table, right? That thing you have to write. So for that reason, I will try to explain with the code. So for example, I am going to have already a table. For example, select star from person 8. I have a table with the name person 8 and having the columns SID and S name. Now I am trying to create another table. Uh, Create table person 9 with the DID. Some meaning is there, assume, right? DID with the D name, right? So when you are going to say this one, you have to define its data type integer, and D name is varchar of 100. Varchar of 100. Now what I would like to say now, I would like to create DID as foreign key to primary key of other table. Primary key of other table. So what I can do, simply I can make write as foreign key of, what is the foreign key here? DID. DID is a foreign key that is going to be references to which table it is going to be referred? it is going to be referred to person 8 of SID. Person 8 of SID. Why it is person 8 of SID? It has to refer because SID is the primary key of other table. SID is the primary key of other table. If I press enter, observe query okay, 0 rows affected. Means it has linked with the person 8 table. Now if I am going to describe person 9, you are going to get the key as multi key. Multi key means what? It's a foreign key. It's a foreign key. Now if I am going to insert some data, insert into person 9 values of 1 comma mechanical, is it going to be inserted? Yes, it was inserted. Try to check the data is there. Select star from person 9. Person 9. Select. I am trying to display other table data also. Select star from person 8. Person 8, right? So guys, here observe SID is 1. So here DID is 1. So why here 1 is inserted? Because this 1 is a part of this SIDs. So that's why inserted. For example, if I am going to insert into person 9 values of here for example 535 comma IT, is it going to be inserted or it is going to be error? It is going to be an error because you cannot able to add or update the child row if foreign key constraint fails. Why foreign key constraint fails? Because 535 is not a part of one of the SID, so you are going to get an error. Right? So this way you can able to use a foreign key sum. But the point here is, if you are going to look in depth about this one, now if you look into in depth about this foreign key, actually when we are going to make the foreign key relationship, we are going to have two types of tables. One is the parent table, another one is child table. I mean, let me take the new slide. See guys, when you are going to apply foreign key relationship of one table, here I have taken person 9 table, right? On person 9 table, and there is a table called primary key, and the table name is person 8 table. Now this person 9 table of SID is depending upon person 8 table of PID. Okay, fine. When it is depending on this one, if something is happened at the parent table, now this kind of table I can call it as a parent table, and this table I can call it as child table. When something is going to happen on the parent table, that is going to be affected in the child table. Yes, means if there is a record called 5 and the child table is created because the record 5 existed, assume if I am going to delete this record, what about the status of this particular record? That's my question, right? Means when you are going to delete something from the parent table, what you have to do, you can able to make cascade. Meaning that when you are going to delete some data from the parent table, you can also delete the child table data. Or when you are going to delete something from the parent table, please set null value for the child data. That is, these are the two options. And in another way, if you are going to perform update operation on update 5 with 6, what about the remaining dependent values? You have to make cascade. Or on update, you have to make set them as null, right? Yes. Meaning that when you updated 5 with 6, you have to make them here as null. Okay, now let's see the another example with respect to this concept. For example, I am trying to create another table. Create table person 10, where here I am trying to define as PID which is of type integer, pname which is of type varchar 10, so varchar of size 10, and here I am trying to define PID as foreign key. So foreign key of, what is the foreign key? PID, which is going to be references to primary key of other table. Other table is person 8 of SI, right? On this, if something is going to delete from the parent table, what you have to do? I am trying to perform on delete cascade mode. For time being, I am going to make the cascade. See guys, you can able to define all the things on delete cascade, and on update operations also we can able to define. For example, if I do like this, yes, table is created. If I am going to describe person 10, yes, it was some description about the person 10 table, because here you can able to observe there are it can able to null values. It can have one primary key. Null means multi-valued attribute. This is what primary key. Okay, when you are going to have primary key, can you able to insert certain data? Yes, select star from person 10. Is there any data is there? No data is there. Similarly, look about the other table, select star from person 8. Some data is there. Now if I am going to into person 10 values of 535 comma something around mechanical. If I enter, you are going to get an error. Why error? Because here PID is a foreign key, means it has to have a values that are the subset of SID, but 535 is not subset of SID, so that is the reason we are going to get an error. So I can make something like 5 if it is going to be successfully inserted. Now I am going to insert one more value. Assume that 1 with the MECH, successful inserted, because these are the part of the values. If I take some 6, it won't insert because it is not part of the parent table. Yes. Now the point is we inserted certain things. Now if something is going to delete it from the parent table, what is going to happen? That is what, right? If I am going to delete from person 8, where assume that SID as 1, where SID as 1, what will happen? So that is what we defined here, right? So we defined as on deleting of the person 8 table, you have to delete cascade on the child table also. So whatever that we are going to delete, if I press enter, query one row affected. If I am going to print select star from person 8, the data is deleted. What about whatever data of person 10? Here also data deleted, because it is dependent. Okay, fine. Let us assume that on update null, or on update set null, or on update cascade, what we can do, right? So for example, I am trying to create one more table on delete set null on update cascade. Means I am trying to define a table called 11, where you can able to, when the parent table data is deleted, child table data you have to make them set null, or when they are trying to update, they have to make them cascade. That's the meaning of it. Table person 11 already existed. I don't know. Let me rename it as 12. Yes, table is created. When now what you can do now? You can simply truncate the both tables. Truncate person, truncate table person 8. Okay, because it has it is like when you are trying to truncate the data of the personate table, it is not truncating because it is referencing a foreign key constraint. So what you can do now? So I will try to delete manually, like delete from person 8, where SID equal to 5. Guys, we have defined this one already. Yes, done. Now if I'm going to define select star from person 8, nothing is there. Similarly, select star from person 12, nothing is there. I would like to delete first. uh, I would like to drop. I would like to drop. Mm, Okay, here I am trying to insert certain data into the data. Insert into the. Okay, here I am trying to insert certain values into the person 8 table. Insert into person 8 values of 1 comma CSC. Similarly, you can go with the person 8 values as EC. I have inserted the data. So can I insert some data into the person 12? Insert into person 12 values of 3 comma mechanical. Is it going to be an error? Yes, it's not going to be an error because it is not sub part of person 8. So I will make here also 1 along with the J. If I enter, yes, it is successful. It is successful. And I made some other data also, 3 comma Krishna. 3 comma Krishna. Yes, 3 is not available there. So I can make use of again 2 only. Yes. Now we have two tables. One is person 8 table along with 1 and 2 values, and person 12 table with the 1 and 2 values. Now, if I am going to delete from person 8, where SID equal to 1, what is going to happen? What is going to happen? Try to observe our constraint. What we did here, you can observe references person 8 SID on delete set null, meaning that when I am going to delete something, it is going to simply place set the value as null in the child table. If I press enter, yes, query okay, one row effective. When you are trying to get the data from the table, select star from person 8, yes, to EC. Similarly, you can be able to get the data from the 12. You are going to get the for same one, you got as null. That's the meaning of on delete set null. Similarly, if I'm trying to update something, update table name is person 8 set SID equal to 3, where S name equal to EC, meaning that wherever EC is there, I am going to set its value as 3. Okay, but it is parent table we are updating. If I press enter, yes, done. Now if I try to print the values, yes, here it was updated. What about the value of 12? It was updated. So here we got updated value, that is 3. So this is the meaning of on update cascade, means whatever the data that was updated in the parent table, the same thing is going to be updated in the child table. Okay guys, yes. So what are the constraints that we have seen so far? All are related to column level constraints as well as table level constraints, right? If you are going to apply on the one particular column, we can call it as column level constraints. If you are going to apply on the like multi columns, we can call it as multi level constraints. Okay, so mean like table level constraints, we can say it as hmm, we are going to simply take the constraint name like check. For example, SID should be greater than 10 and S name equal to VIJ. This is what you can call it as multi-level constraint, meaning that on two particular columns, I am going to update the constraints. So this condition has to satisfy if it has to be inserted to the table. So If you are going to combine multiple columns, I can call it as table level constraints. Okay guys, so this is the concept of various kind of constraints and keys. In the next class, we'll try to explain the complete one practical example related to all these constraints as well as keys.